Good morning and welcome to today's webinar. My name is Aranza Zugalan and I'm a member of the Build Up editorial team.
Welcome to Build Up, the European Commission's portal for energy efficiency and renewable energy in buildings. Directly stemming from the Energy Performance of Buildings Directive, Build Up is the meeting place for everyone involved in making the European building and construction sector more energy efficient. Every month we focus on a topic that is key to making Europe's buildings as energy efficient as possible. Exploring that, you can find the latest content such as expert talks, webinars, case studies and more. From architects and engineers to academics and policy makers, we've got you covered. Build Up brings together thousands of registered members to reap the benefit of Europe's collective intelligence on all aspects of energy efficiency and renewable energy in buildings. The Build Up portal benefits from the expertise of our ambassadors. Drawn from industry and academia, the ambassadors bridge the gap between EU and national level and help shape our editorial content. Want to promote your work? Build Up disseminates your research, projects and events through a variety of channels. Become a member to exchange knowledge with your peers. You can disseminate tools and resources, share good practices, and consult open source publications. Join the discussion on social media and become part of the Build Up community, or subscribe to our newsletter to receive the latest news. However you participate, the Build Up portal is here to inspire, inform and connect. Build Up, the European portal for energy efficiency and renewable energy in buildings. Join the community for opportunities and updates.
Good morning. It is a pleasure for Build Up to host today's webinar entitled COGITO Digital Twin Platform and Data Visualization Tool, brought to you by the COGITO project. This webinar is the fourth one out of the series of 5 webinars titled Practical Tools for the Construction Sector in Digital Twin, organized by the COGITO team and Build Up platform. The aim is to present the COGITO Digital Construction 4.0 toolbox and gather important feedback from the audience. The session today will be as follows. We will begin with a brief overview of the COGITO project from Giorgos Giannakis, PhD at Hypertech Energy Labs. There will be a short Q&A after the introduction. This will be followed by a presentation on the digital twin platform from Kyriakos Katsigarakis, research fellow in BIM platforms and data integration at the University College in London. There will be a demonstration video and a Q&A after the presentation. We will then hear a presentation on the data visualization tool from Giorgos Giannakis, PhD at Hypertech Energy Labs. This presentation also includes a demonstration video followed by a Q&A. We will then round off today's session with a short poll to collect the audience feedback. Please remind that you can answer to this poll in the chat. We invite and encourage the audience to send us questions through the GoToWebinar platform that can be answered during both Q&A sessions. Please specify if your question is for a specific speaker or if it's for both speakers to answer. Before we begin, we would like to bring your attention to the webinar control panel on your screen, where you will find 2 documents under the hidden handouts. These 2 are the deliverables that support the information in today's session. Additionally, you will be able to find the webinar recording on the Build Up portal and our YouTube channel in the coming days, together with the presentation slides. And now, without further hesitation, we will move directly to our first speaker of today, Giorgos Giannakis, PhD at Hypertech Energy Labs. Giorgio, the floor is yours.
Thank you. Can you hear me?
Yes, we do.
That's great. So I do have the control of the presentation. Great. So back in 2020, when developing the COGITO proposal, a thorough desk search revealed the construction phase had been overlooked by the digital twin community. where many studies highlighted the lack of commonly agreed standards and low interoperability among collected data are considered major drawbacks to the enterprise's digital transformation. Delving deeper into the source of the problem and searching for ways to address those drawbacks, we witnessed the need for going beyond static big information modeling by leveraging technologies like IoT, cloud computing, and artificial intelligence, highlighting the need for a construction phase digital twin model. A digital twin model that encapsulates mechanisms like protocols and platforms to share the data across various stakeholders, enabling the development of new solutions and services for the smart construction of infrastructure. To address those present challenges in the construction industry, COGITO set out to create a cutting-edge digital representation of construction projects using innovative methods to ensure seamless collaboration among various components and technologies within a digital twin ecosystem. So who we are? The COGITO Consortium is an alliance of 13 partners from 7 European countries, covering the entire construction value chain. Our missions have been to craft a digital twin platform powered by AI-driven quality control, workflow management, and health and safety digital twin applications to demonstrate them on actual pilot construction projects to pave the way for compliance with industry standards and to extensively disseminate our achievements. To that direction, the conceptual COGITO architecture was developed. So let's delve deeper into the COGITO solution. Actually, the COGITO solution hinges on several key components. The COGITO Digital Twin platform in the middle, which is the cornerstone of our system that masterfully manages data in adherence to the COGITO data model, ensuring seamless semantic interoperability among the various digital twin components. The multi-source visual and IoT data pre-processing modules on the left that transform raw reality captured data into curated information that is stored in the digital twin platform. And on the right, the health and safety services that generate hazard detection rules based on design and planning, issuing also timely warnings to construction workers and equipment operators using real-time data. The quality control services which retrieve both as designed and as built data from the digital twin platform, expertly detecting defects and discrepancies using advanced algorithms. The workflow modeling, simulation and management services that monitor and optimize construction processes in terms of cost and time. And last but not least, our rich graphical user interfaces and supporting application designed to empower decision makers and streamline progress reporting for all stakeholders. Fast forward 3 years, and we are thrilled to share that the consortium has successfully developed 14 digital tools, including responsive multimodal user interfaces. These tools have already been demonstrated in a linear infrastructure project in Munich, Germany, with an exciting showcase planned for another actual construction project in Murcia, Spain. Okay, concluding this presentation, and as we dive deeper into today's webinar, today we'll shine a spotlight on our two core tools, the Digital Twin platform, the central hub for data sharing and semantic interoperability, and the 3D web app, the DCC, Digital Command Center, that offers an immersive representation of construction site digital twins results. Back to you. Thank you for giving us the opportunity to present today those tools.
Thank you very much, Giorgos. Thank you for developing 14 tools. That's absolutely outstanding. And perhaps here comes the first question. How do you foresee the user spread of these Cogito tools in the current construction market, and what are the next steps?
Yeah, actually, let me explain that we're talking about a low TRL solution that was developed within Cogito. So despite the fact that we put a lot of effort to disseminate and exploit our results, I wouldn't say that the solution that has been developed and all of those tools that are depicted here have reached the maturity level that would be required to put them on the market. However, we foresee to continue all our efforts. We do have adequate time, around 8 months, to exploit that opportunity as well, and put all the tools that have been developed in the market, receiving at first feedback from all stakeholders that have been engaged in demonstration activities that I mentioned before in both pilot sites.
Okay, perfect. So it's true that the construction industry, at least in Europe, we are in a desperate need of an improvement. And do you think that in your experience with Cogito, there are opportunities associated with the widespread of artificial intelligence and digital tools in our sector?
Yeah, actually, there are many challenges to achieve that, as you are aware. For example, I would say that despite the fact that the construction industry often deals with various data sources, as you know, and ensuring the quality and seamless integration of all those data for digital twin applications can be challenging. So establishing something like standardized data protocols and investing mainly in data quality assurance can enhance the reliability of all the AI-driven digital twin applications. Apart from that, we all know that there is lack of interoperability between the different digital sources, tools, and platforms used by various stakeholders in the construction process. And actually, this is another challenge to be considered. To this direction, standardization efforts and open platforms can facilitate interoperability, allowing for more seamless integration of AI, BIM, and digital overall technologies. And this is something that we put a lot of effort to achieve within Cogito. Another challenge, as we all know, is the initial costs associated with implementing digital technologies. That may also be a barrier for some construction firms, especially for the smaller ones. Here, I would say that government incentives, collaborations, and technology sharing initiatives can alleviate such financial burdens and promote widespread adoption. A last challenge that I would like to highlight is that it comes as no surprise that there is a shortage of skilled professionals proficient in both construction and digital technologies. And this actually limits the successful implementation of digital twin applications. Here, I would say that investing in training programs and fostering collaboration between educational institutions and industry can help build a skilled workforce.
Awesome, Giorgos, you have opened the Pandora box in skills, right? But also we know that digitalization is a big asset to improve skills in construction. So it's something that we can explore in further, because we will continue to follow Cogito very closely, because you continue to have reports to upload in your portal. So let's go to continue to know more about digital twin platform with Kyriakos Katsigarakis. Kyriakos, the floor is yours. Thank you very much.
Hi, yes. Let me check if I can control the slides. Okay. So yes, the digital twin platform is a data integration middleware, cloud-based data integration middleware. Of course, that plays a central role in the COGITO solution. It contains 6 core layers, software abstraction, software layers, and is responsible to load the input data coming from the BIM authoring tools, the 3D BIM, and the construction, the project management, the construction schedule, and of course data coming from IoT devices for the location tracking and point clouds and images. So when the data ingestion layer loads this data to the DTP, to the digital twin platform, the DTP performs quality checks. And if the data are the quality is okay, the data are loaded into the data persistence layer. The data persistence layer is a combination of relational databases and graph databases, and the knowledge graphs are populated based on the COGITO ontological network. We have an ontology, defining our own ontology in the COGITO that covers different domains, information domains, for example, the process for the tasks and work orders, the quality, the health and safety, and the facility as well for the topological structure of the construction project. And then the digital twin platform at the top has the data management layer that is possible to respond to the data requests of the various COGITO applications using REST API, synchronous communication or asynchronous notification channels is also available through the messaging layer. The digital twin platform also offers the authentication layer in order to authenticate users, to define their roles, and also to authenticate the applications, the COGITO applications. And also we have defined the data post-processing layer that is responsible to process B models, the data that are complex, have complex data processing. So on the next slide, the overall architecture, as I said, has 6 core layers. Each layer contains software components. Here, the important thing to mention is that some of these components are standalone applications, but also in the data management layer and in the data ingestion layer, we follow the microservice architecture. And in the data post-processing layer, through the messaging layer, we implement the service-oriented architecture in order to communicate with the COGITO tools. The digital twin platform offers graphical user interfaces for users that they have different roles in the COGITO solution. For example, the COGITO tool developers, they have access to the digital twin platform in order to register their own applications, to configure the APIs of their tools, and also to create and configure and orchestrate execution of the internal services and model checking services and data transformation services that the DTP offers. Also, the project managers have their own access to the digital twin platform in order to create projects, to configure the projects, to assign users to the projects, and to load the input data. For example, as I said before, we have the BIM model, we have the construction schedule, we have IoT data coming from the construction site. So all this information, the project manager has the responsibility to load this data into the digital twin platform. The quality assurance is a very important part. So within COGITO, we have defined our own BIM modeling guidelines in order to prepare the model, the 4D BIM model. So as you can see in this table, we have specific property sets for the construction zones and the building elements that are available in the BIM model. So we encode all this information using the model view definition specification in MVD XML format, and then the data, the BIM model. When we upload the model in the digital twin platform, the digital twin platform can automatically check the completeness of the model, and this is very useful. Also, we offer the geometric class checker. That is a tool that is responsible to detect classes and containment errors in the model. These error reports are very important because in some cases we use these error reports in order to enrich, semantically enrich the graph databases that we have in the COGITO, in the digital twin platform with additional information. For example, as you can see in this image, we have a construction zone and the railing element that we have a class, and then we can, for example, create additional semantics that this construction zone has these elements. The digital twin platform also offers a set of data transformation services. We have internally built an IFC optimizer that reduces the size of the BIM models, and this is super important when we have to deal with the large models, because we can speed up the execution of all the data transformation processes and model checking processes. We have also a BREP generator component that is responsible to create triangulated representations, geometric representations of the BIM elements. And this is important because also we offer in the COGITO solution connectivity with AR headsets such as the HoloLens, and it's important to have an optimized way to visualize the geometry in these devices. Digital twin platform also offers a knowledge graph generator that is a tool, a component, internal component responsible to transform all the input data, the BIM model, the construction schedule on this information into the knowledge graphs, and also to create the thing descriptions that are stored in the thing description directory. We have this technology that follows the Web of Things specification. And finally, the BIM management components, it's a service that is built inside the digital twin platform and is responsible to provide the functionality to the digital twin platform for serializing, deserializing, querying, merging, splitting, and manipulating BIM data in general. Now, about the data integration and interoperability problem, the digital twin platform offers here an extended way that we can configure our own scripts. So the digital twin platform offers a DT library that contains a set of reusable ready-made blocks, scripts, that they are registered through the graphical user interface, and then the COGITO tool developer can create the modules based on these actors. So with an empty canvas, she can drag and drop actors in the module design platform and to configure all the routes and the business logic of the module. So this is, I think, the last slide. We can switch to the video for the demonstration.
Yes, one moment.
Yeah, sorry. The COGITO tool developer, as we can see here in this video, can register their application. So, for example, here, the process modeling and simulation application, we have created this application. And here, for example, we can add an endpoint in order to interact with the digital twin platform for the specific request. We can create data collections, and each data collection is just an abstraction in order to receive files with annotated with a project ID. And for example, here we can demonstrate the creation of a module. For example, if a tool, for example, the PMS wants to send to the DTP the updated process model, that's a JSON file. We have this empty canvas, and the developer can very easily drag and drop actors, these coding blocks, and to define the business logic of the module. For example, here we initialize the execution of specific ETL. We receive a JSON file and we configure all the parameters, the necessary parameters. And then after the execution of this ETL, that is COGITO specific, of course, ETL, we define how we are going to store the file in the DTP and how we are going to update the graph. And now, if we activate the module, we can start the DT runtime environment. And then if we go to the endpoint that we previously generated, if we change the status of this data collection, we trigger the execution of the module, and then the DTP generates the output of the execution. Now, for the project managers, we offer a basic interface in order to create projects. And in each project, we can assign users that they have previously registered through the identity provider. And the project manager also has the functionality to edit the roles of each user. So we have access to all policies in the DTP. And the next step for the project manager is to upload the input data. So we have a core endpoint in order to create a data collection for the project, and then to upload the IFC file, the construction schedule, and the resources, all the input files that are needed. When the annotation is finished and the execution is triggered through the status update, the DTP checks the quality and also transforms the data to the graph, RDF data, and also updates the graph. And here we can see a model checking. So we provide an error report for the elements that have missing properties. And here this can help the designer in order to go back to the BIM authoring tool in order to update the properties. Here is more complex modules. For example, this module is responsible to generate an IFC snapshot, a smaller IFC that contains only elements that are active for a specific period of time, that we have tasks, active tasks. So applications such as the AR device, Unity applications that are installed in the AR devices, they send to the DTP time range, and then the DTP on the fly generates an IFC file, a BIM model that contains only the active elements based on the input range, time range. So this is an output, as you can see here. And that's all. Thank you. Any questions?
Thank you very much, Kyriakos. We have a first question on our audience, that is why you have included a data persistence layer, and perhaps for those that don't know what is it, a brief explanation of what is it.
Yeah, okay, the data persistence layer, it's the layer that, because we have the execution of the various ETL tools, so we have the input data with specific guidelines. The project manager or the team that's responsible for the construction schedule should prepare the input data. And then we need to transform this data according to the ontology that we have, the data model that we have defined internally in the COGITO. So the data persistence layer stores the information that is loaded from the input data, but also during the phases, the planning phase and the construction phase of the project, the various COGITO applications send back updates, images, videos, point clouds. So there are the IoT data, the location tracking data. So all this information is managed in the data persistence layer, and that's why we have a system that is able to store this information the raw data, and at the same time to update the knowledge graphs in order to be able to retrieve this information later back. So we can execute complex queries and Sparkle technology or RDF technologies in order to get back updated data.
Thank you. So complete, yes, perfectly understood. You have also told us that you have created your own BIM model to run over the digital platform. How large can the 4D BIM model could be?
Yes, so this is a very good question because within Cogito, in the pilot sites and in the pre-validation sites, we have dealt with this problem. When we are talking for construction sites, for example, roads or railing that is a few kilometers, or maybe large projects, it's very important that the digital twin platform can handle this complexity of the models and in general the big data. So there are more than one possible solution. It depends on how the construction project is organized. So, for example, if we have different construction schedules, splitted, maybe we can introduce in the digital twin platform more than one project. This is one solution, and to split the big model in smaller projects. But when this is not an option, we can of course deal with to load the big model in the digital twin platform, and then we have some internal modules that they can produce smaller visualization files and to split internally the project in order to share the data with the Cogito applications that have limited capacity. For example, when we are talking for an AR device, HoloLens, for example, that we use in the project, we have specific capacity of RAM and CPU, so the DTP should provide the correct data to the application. So we deal with this as well.
Mm-hmm. And that is affect the execution time of the ETLs and the model checking services?
Exactly. That's why we have the service-oriented architecture connected with this data post-processing layer is connected with the DTP with the core components of the DTP using this messaging layer. We are talking for asynchronous communication, and what we do with this. So when we have a big model and we have to execute an ETL that takes time, for example, the model checking, we submit the job to the service, and when all the communication is asynchronously, so we execute the service. When the service finishes after 1 minute or 10 minutes or half an hour, doesn't matter, the DTP receives back a notification from the service, and then the DTP forwards the notification to the application, and so we can handle these interactions with the end users and to notify the users using emails or notifications in the applications for that the execution is finished and the response is ready for them.
Awesome. We were talking before that you were very happy because you have achieved all the goals of Cogito. And in this step, can the digital twin platform be used for use cases beyond the scope of Cogito?
Yes. So this is something that we consider from the beginning. The solution that we present here is a data integration middleware in general. So of course, all the ETLs, the actors, the scripts that we have included at the moment in the digital twin platform are designed and developed in the work package, in the corresponding work package with other partners, and are aligned. These ETLs are aligned with the Cogito ontological network at the moment, but the solution is generic, and there is no any blocking point to add additional use cases within Cogito or outside the Cogito to use this as a data integration middleware, as a generic solution.
Mhm. And as today is the last day of the project, so 31st of October, what are the current limitations of the platform, and are they expected to be overcome in a future project, or they are easy to overcome, taken by any of the project developers?
Yeah. The limitations of the platform at the moment, I don't see any limitations related to the use cases that we have defined within COGITO. But of course, there are some challenges. For example, the functionalities like that I demonstrated before at the IFC snapshot. Some parts of the digital twin platform right now have been developed in order to demonstrate the technology, and there is a lot of optimization that can be happened behind in order to have faster executions. So one limitation maybe is that we can achieve faster executions and have a better integration and faster executions in general with tools. Of course, this is a complex problem because we are dealing with BIM data that are complex, and the IFC schema is a complex schema. But I think that we are in good. We are ready to do that work because we want to continue working on this.
That would be absolutely outstanding. And a very last question. You were talking about project managers using the platform to include
Yes.
data. And how user-friendly is the platform?
Yeah, at the moment, it's not. This is maybe another limitation of the platform. That the platform, as Giorgos said previously about the TRL of the project, so we managed to provide a very basic user interfaces in order to load and execute all these complex ATL tools and model checking tools. We can, for sure, there is a possibility to improve this. The project management and the file execution, orchestration of the services, and also all the files that are generated from the different ETLs. Right now, we have a file storage system in the business layer that we store this information. Maybe we can create better views for this data file repository. And maybe this is another thing that we will do in the future.
We're looking forward to it, Kyriakos, in fact, and hope that build-up is helping and following you in the way of this, improving the TRL of the COGITO. Thank you very much. We go back to Giorgos, that now we will present this data visualization tool part. Thank you very much, Giorgos. The floor is yours.
So it's me again. Actually, in this slide, we are exploring the key features and capabilities of the DCC module, which stands for the Digital Command Center. Actually, this module is a powerful 3D visualization tool that offers a holistic view of a construction project's digital twin. It's user-friendly, web-based, and accessible from any device or operating system, providing a remote but detailed view of the construction site. In more detail, DCC as a 3D visualization module leverages data from our COGITO Digital Twin platform that was presented earlier by Kyriakos, to create an off-site graphical representation of the construction site. It features an intuitive user interface based on the popular 3D game engine Unity. And through DCC, the user can get a detailed view of the construction project's timeline with the as-planned for the data, filtered by works execution schedules, as well as build data showing what has been constructed in a specific time frame. DCC also offers visual overlays that report on crucial project aspects, including work progress, potential health and safety concerns, the quality of work, and resource allocation data. This means that the user can monitor and manage the construction project with precision, efficiency, and safety in mind. Upon successful login and project selection in DCC, that we'll see later on in a video how this happens, the user is presented with the main application layout as depicted in the left side screenshot of this slide. The main UI components available to the user are the filtering bar, allowing the application of filtering criteria, namely time interval selection for the as-planned and as-built data. The camera widget assisting the navigation of the user throughout the 3D model. The element tree panel listing all elements available in the beam in two alternative hierarchies. The element detailed panel populated upon bin element selection, providing all available data properties and attributes for the specific element. The overlays selection, allowing the user to visualize available metadata on top of the rendered beam elements. And the status bar providing information about the connection, the logged in user, and the DCC version that is running. The overlay selection buttons actually allow the user to enable or disable each of the four foreseen available layers corresponding to the data generated by the relevant digital twin applications and stored in digital twin platform, namely the work progress COGITO tools, the IoT location data pre-processing tools, the quality control tools, and the health and safety tools. Actually, the quality control and the work progress overlays have been discussed and presented in previous webinars, where actually the quality control overlay allows the user to visualize the results obtained via COGITO visual and geometric quality control tools, while the work progress overlay provides a quick, straightforward visualization of project's current construction status. And for the specific overlay, upon application of that overlay, the project's beam elements are color-coded according to their construction progress. The video that follows today focuses on the health and safety and the IoT overlays of our solution. So can we move to the video, please? Okay, the journey in DCC starts with a login modal window where the user enters his or her credentials. Then the user selects the project that he or she would like to view, and the DCC application starts executing the required conversion reporting operations. Upon successful login project selection, the user is presented with the main application layout, where he or she can zoom in, zoom out, or rotate the building rendered geometry. A camera widget is always available at the top right corner of the screen, where, for example, clicking on the x-axis moves the camera to a side view. The element tree view that we see on the left panel provides a hierarchical view of all elements grouped by story by default, and each item or group in the tree view has separate show or hide controls in the form of an I button. Clicking those buttons hides or shows the corresponding elements in the 3D skin. Selecting an element, either by clicking on an item in the tree view or using the mouse in the 3D skin, will populate the element details panel. The latter actually includes a property table with all available attributes and metadata linked to the particular element. To avoid cluttering the UI, the element tree and element details panels can be collapsed or expanded as per user preference. The element tree panel also provides an alternate grouping mode by element type, where actually the user can toggle between the two modes using the header button. The expanding, collapsing, and showing, hiding functionalities remain the same for both grouping methods. At this point, I would like to mention that upon project initiation, no time filtering is applied. However, the user has the option to filter the displayed elements by date range, setting the start and the end dates, and selecting the as planned data filtering to be applied. Changing the start or end dates, all elements that have their as planned dates within the selected range are shown only. For the health and safety overlay, actually, it makes use of the enhanced BIM file generated by another COGITO Digital Twin application called SafeCon AI and stored data in the Digital Twin platform. The relevant data fall under two main groups, safety elements like railings and safety zones that can be hidden or unhidden using the I button. The user can browse a list of various safety-related zones and visualize them that are further grouped into three main categories, namely the potential movement spaces, the fall spaces, and the fall hazard spaces. Upon their selection, they are rendered as rectangular bounding box that include the area of interest. As planned or as built time framing filtering could also be applied here, as we see. So selecting no filtering, disable any time frame filter, and click again on the health and safety overlay button hides any information relevant to that overlay. Click now on the IoT data overlay. The tracking of entities capable of moving within the construction site, namely humans and machinery or heavy equipment, is enabled. The available track entities are grouped by type and are displayed as 3D pins of different color per group. The user can hide or unhide specific entities or group of entities, and clicking on the left arrow at a specific element, check the coordinates of each location of the specific entity, as they have been tracked by the IoT data preprocessing module of the COGITO solution and stored in the Digital Twin platform. And this concludes the demo of DCC prepared for our webinar today. Thank you.
Thank you very much, Giorgos. Perhaps the first question for you is if you can elaborate a little bit more on the technology stack used to develop the digital command center module, and specifically how it integrates with the COGITO's digital twin platform.
Yes, sir. Thank you. Thanks for the question. Actually, as Kyriakos mentioned, apart from GCC, there are other applications that were developed using the Unity game engine. So targeting to a common look and feel end user experience within COGITO, at first we developed the COGITO Unity library, which is actually a collection of C# scripts that is delivered in the form of a Unity package. And actually, this library provides methods to obtain the IFC file and convert it to mesh type files with accompanying metadata, enable the communication between the digital twin platform and applications that use the specific COGITO Unity library, and all the functionalities that were demonstrated in the previous video. As for the main packages, frameworks on top of the COGITO Unity library, I would say that the Unity game engine, WebGL, IFC OpenCell, and the ArcVenture IFC importer from the Unity Asset Store properly modified and extended to meet the COGITO requirements, have been used and shape the technology stack of DCC. As for the communication integration with the digital twin platform, the data querying and retrieval information from the digital twin platform is mainly achieved through RESTful API calls to tailored endpoints exposed by the digital twin platform.
Awesome. So let's say that through the digital twin platform, you have achieved the integration of the digital twin APP and the digital command center with the building information model. quite impressive. How does this integration support the sustainable construction practices that we are pushing to achieve here in Europe?
Yeah, actually, I'll answer your question, but at first I'd like to a bit rephrase the question to something more generic. For example, integration of digital twins with building information models to support the sustainable construction practices. So to answer that question, I would say that digital twins provide a near real time visual representation of physical assets or processes, thus enabling dynamic monitoring and analysis of construction project. When integrated with BIM, this synergy could offer several benefits. I would highlight the most important, at least from my side. First, the digital twins combined with BIM enable a comprehensive live visualization of construction projects. And in fact, the near real-time monitoring capabilities of digital twin applications that are integrated with BIM data allow for continuous performance evaluation. And this helps identify insufficiencies, health and safety risks, and other factors influencing sustainability. And note here that such an evaluation, although focused on the construction phase within COGITO, may be seen as a holistic life cycle assessment of buildings or infrastructure that includes evaluating environmental impacts from the construction phase through to operation and eventual decommissioning. In my opinion, though, the most significant benefit is that digital twins integrated with BIM foster collaboration among various stakeholders. And when actually open formats are selected for data integration and sharing through a unified digital twin and BIM environment, like the digital twin platform that was presented earlier, this collaborative environment promotes sustainable practices by ensuring that all parties involved have access to accurate and up-to-date information, supporting this way informed decision making. So concluding my answer to this question, I would say that overall, enhanced visualization and simulation, performance monitoring and optimization, collaboration and coordination are benefits that could be offered from a digital twin applications and BIM synergy.
Not bad at all. In fact, you said a phrase in your previous one that is data collected is transforming to valuable information. I think that is key because data is nothing without the transformation, and your platform is for sure breaking the silos that we sometimes have in the communication in between actors. You have passed by also in your previous and also Kyriakos from pilot sites. So there is one in Murcia in Spain. Are there already outcomes that support all the work that you have done in Cogito?
Yeah, actually, within Cogito, we had two pilots. We have two pilot sites to perform all our demonstration activities. We have already performed all the demonstration of the 14 digital tools in the first pilot site in Munich, Germany, which is actually a linear infrastructure, a quite big linear infrastructure project. We have collected results, and currently we are assessing the impact of our tools to the specific project and the stakeholders that were involved. Whereas for the second pilot site, we are currently planning the demonstration activities. And if I'm not mistaken, they have been planned to be performed within January. Currently, we have collected all the information with regards to the asphalt data, and I'm referring to the B model that fulfills the requirements of the project, but also the scheduling information of activities that will take place there, construction activities. And we have planned all the activities relevant to demonstrating our solutions, but also collecting as-built data from the site. I would say that we will conclude all our demonstration activities, hopefully, if we succeed, and I hope so, by the end of February, mid-February, something like that, including the assessment of the impact to all the domains that we are touching upon within Cogito. And I'm referring to health and safety, quality control, and the workflow management.
Perfect timing, and be sure that build-up will be there with you. And a final question that I believe that is in the head of all of us after your presentation, that is, when will the COGITO solution be available on the market?
I think that I already touched upon that. As I mentioned, yeah, it would be great for all to have a product as an outcome of our activities within the project. But to be honest, as I mentioned, we are reaching not that much high TRL of our solution. Despite that, we do put a lot of effort to provide something that could be used by other professionals in the ARC industry, BIM professionals, educational institutes, and so on. So I do not have a clear answer about if at the end we'll manage to put all those tools that have been developed within the project to the market. But I hope that we will have an opportunity in the future, maybe another project to be funded, continuation of Cogito that will give us the opportunity to reach a higher TRL of our solution and put the overall solution integrated, fully integrated into the market.
We really hope so for that, because it's most needed, and there is an incredible baseline what you have created with Cogito Digital Platform here. So dear audience, let's go for the poll that our speakers are proposing to you. You can answer on your screens, and if you want to say something others, you can specify in the chat. So let's open the poll with the first question. What best describes your current role or job function? So let me know. We have a architectural engineer or construction or BIM professional, a software engineer, project manager, researcher, or student, or other. If you are other, specify in the chat, please. Okay. Let's go to the second question. Perfect. So we are a lot of researchers here. I believe that some we are double helmet, what is very interesting also, bridging the gap, and quite curious to see that we don't have architectural construction or professionals point taking for build up. Let's go to the second question, please. How did you find out about this webinar? So by social media, for example, LinkedIn, Twitter, or the new X, the Cogito website, our referral from a colleague, or others. If so, specify in the chat. Social media could be through the Cogito social media or build up social media, for example. Interesting to see in the chat if you follow build up. Let's go to the answers, please.
People still responding, so I'll go in just a second.
Ah, okay, sorry. Just let me know because I don't see the movement.
Yeah, I understand.
I'm a quickie. I will say here, if you have not visited the Cogito website, it's really well done. So, and they uploaded much content. It's very updated. Great. So mainly social media, point taking, and referral from a colleague. That's good. Hope parties from the built up portal too. Let's go to the third question, please. Where would you prefer to receive updates about our digital twin tools and related content? Would you like to be in the newsletter? By social media, LinkedIn and X mainly, webinars and virtual events, the Cogito website, or any other? Here I can remember you that we have absolutely everything in build up. So we have a monthly newsletter based on the topic of the month. Next month of November is going to be buildings as energy generators. So keep posted. We have the social media. You have the channels of LinkedIn, Twitter, but also YouTube, where you will find all the webinars that we promote, and expert talks, for example, with the actors, also people from Cogito. So you can check there and use it as a database for information about energy efficiency. Let's go for the answers. Perfect. So mainly social media and the webinar and virtual events. That's perfect. Again, I will propose you to visit the Cogito website if you are not familiar with it, because they really make a work in maintaining it updated. Let's go to the fourth one, please. Would you be interested in a live demonstration of our digital twin platform and or the digital command center? Yes, both. Yes, mainly digital twin platform. Yes, mainly the digital command center. Not interested in demonstrating. I will say yes, both. On my side, I cannot vote, but we want more. we're in build up. We will be treating the construction 4.0 in the months of 2024. It's already, we will keep you posted about the month, but we will sure have the Cogito team again with us to further explain us where are they. So let's see the answers, please. Okay, so 2/3 prefer to have knowledge about both. That's very rewarding for the team and for us. And fifth and last one, please. So have you attended previous Cogito Tools webinars? If yes, please select the tool set that you found most interesting. So the digital twin data management integration and visualization, digital twin applications for health and safety, digital twin applications for quality control, digital twin application workflow management and optimization, or you have never attended any of the previous webinars. Remember that this is the fourth one with Build Up, and we continue to have one more coming. So do we have the answers already, Emily?
Yeah, in just a moment, there's a few more answers coming in.
Okay, the Cogito, one of the Cogito project managers, invites all of you to the YouTube channel of Cogito, that they also have a YouTube channel, and there you can see all the recordings and the webinars. And yes, you can see in the chat that they are proposing you also the contact for the question 4 of the demonstrations if you want to know further. And here, unfortunately, 50% didn't attend the previous webinars. So go to Cogito YouTube channel or Build Up YouTube channel. It was a series that we created together. There is one more coming in early 2024. And here I will say goodbye, and a big thank you to the speakers and also to the audience for attending today's webinar. A reminder again that you will be able to find the recording of today's session on the Build Up portal and our YouTube channel in the coming days, together with the presentation slides. We have many webinars planned for the second half of 2023, including some very interesting interactive sessions as part of the series with the Bus Go Circular project. And we also are looking forward to the 5th and final webinar of the Cogito series planned for early 2024. So keep an eye on the Build Up calendar and our social media for updates on this. We wish you all a very pleasant week. Thank you again to our very inspiring speakers. Thank you and goodbye.